Hey guys, welcome back. In my last video series, we went over solving quadratic equations. In this video series, we are going to work on solving other types of equations. I'm going to explain what those other types of equations are and exactly how to solve them. There'll be a separate video for each of these different types of equations, so be sure to check them all out. So let's go ahead and get started. Alright, so we've got 5 different other types of equation. They're listed here: polynomial, radical, rational exponents, quadratic formula. Those are ones that are in the quadratic formula, but they're different, and we'll check those out, and absolute value equations. In this video, we're going to talk about solving polynomial equations. So what are polynomial equations? Well, we've looked at a lot of them already. For instance, 3x plus 2 equals 10 is a polynomial equation. X squared plus 3x plus 5 equals 0 is a polynomial equation. And the order of the polynomial equation is determined by the value of the highest exponent. So if we look here, we have 1x, and this is really x to the 1. This is what we call a first order polynomial equation, and that's just linear. That's a linear equation. That's an equation of a line. Here we have an x here and an x here. We can see that our highest order is 2. Our highest value of our exponent is 2, so this is a second order polynomial equation, and that's just a quadratic equation. So that's something that we've also already looked at. So if we have things like x cubed plus 4x squared if the highest order is cubed, that'd be a third order, and so on. So we're going to look at some equations that the highest order is larger than 1 or 2. So let's go ahead and jump right in. So here's our first example, and how we're going to solve actually all of these equations are by factoring, which is extremely similar to what we did when solving quadratic equations. So once you kind of see how to do it and get the hang of it, it's going to be just like what we did before, and so it should be very comforting, and you should kind of get into a pattern of what you're used to. So let's go ahead and look at this one. Well, the first thing we want to do is we want to see, what do these terms have in common? We already have all the terms on this side, on the left side over here, and we have equal to 0. So that's kind of our first step, and this one, it's already done for us. So now we want to look at, what do these two terms have in common? Well, if we just look at the coefficients, we have 5 and 20, we can see that both of those are multiples of 5. So we can take the 5 out. If we look at our x's, we have x to the 4th and x squared. Well, that means that both of them have an x squared, because we can think of x to the 4th as x squared times x squared. So we can take out an x squared. Now, what does that end up giving us? Well, we know that we took out the 5 and x squared, so here we just have x squared. We have a minus here, so minus 5 times what will give us 20? Well, that's 4. And x squared, we don't need anything else there, because 5x squared times negative 4 is going to give us negative 20x squared. And still we have this equal to 0. Now, by the zero product property, we can set both of these equal to 0 to solve for x. But I want to point something out here first. This x squared minus 4 is a difference of squares, and that's when we have something that looks like a squared minus b squared. And we can factor that to a plus b times a minus b. So we can see that this is x squared minus 2 squared. So that'll give us x plus 2 times x minus 2. And that's just following this equation right here. And if you want to FOIL it out to see that you will get x squared minus 4, I encourage you to do so that you can become comfortable with that. Now that we have all 3 of these terms, we can set each of these equal to 0. 5x squared equals 0, x plus 2 equals 0, x minus 2 equals 0, and then we solve for x. We divide both sides by 5 here. We get x squared equals 0, so x equals 0. obviously anything that's multiplied by itself that'll give us 0, that's only 0. Only 0 times 0 will give us 0. So that's the only solution to that one. Here we subtract 2 from both sides and we get x equals -2. And here we add 2 to both sides and we get x equals 2. Now these three answers are our solution set. So we have -2, 0, and 2. And I want to point out that if we didn't take the difference of squares here, that if we just went ahead and used the zero product property straight off, we would have 5x squared equals 0 and x squared minus 4 equals 0. So again, this will give us x equals 0. This one, we add 4 to both sides and we get x squared equals 4. Take the square root of both sides by the square root property, which we did in our quadratic equations. To remember, take the positive and negative. So we get x equals plus or minus 2, which gives us the solution set 0, -2, +2, which is the exact same as what we did when making it to 3 different factors. So if you're uncomfortable with the difference of squares, you can use other methods that we learned in solving quadratic equations to solve. So you don't have to do that. And so that should make you feel a little bit more comfortable if you're not super comfortable with the difference of squares. We can solve it using the square root property and get the exact same answer. Now you can take any of these 3 solutions that we came up with and you can put them back into our original equation to check that that does in fact equal 0. But if you have your algebra right, you should feel pretty confident that your solution set is correct, but it's always a great idea to check because then you know 100% those are the correct answers. So let's go ahead and take a look at another example. Now, as I said before, we want to have equal to 0, which means we need to move everything to one side. Now, I'm going to choose to move these terms on the right to the left, but I do want you to know that if you're more comfortable moving the x and the 1, you can move the x and the 1 to the right instead, and it doesn't make any difference. You'll get different negative terms, but in the end, it'll cancel out and you'll get the exact same answer. So whichever way you're more comfortable with, as long as everything is on one side of the equation, it doesn't matter what side that is. So to move these, I need to subtract 9x cubed from both sides. We have minus 9x cubed. I need to subtract 9x squared from both sides. We have minus 9x squared. And 9x cubed minus 9x cubed gives us 0. And 9x squared minus 9x squared gives us 0. And 0 plus 0 gives us 0. So we now have everything on the left side of the equation. And here we're going to factor again. So we can see that both of these have negative 9s in them. So we'll take out a negative 9. And then as this is x squared times x cubed, we can take out an x squared as well from both terms. So we'll have x plus 1 minus 9x times, well, we know that this is x squared times x. We have x. And negative 9x times what will give us negative 9x? So negative 9x squared times what will give us negative 9x squared? Well, that's a positive 1. Now here some people can have difficulty because they have trouble seeing that we can in fact now factor out this entire quantity of x plus 1. Now remember that x plus 1 is just like 1 times x plus 1. Now if we had this as u minus 9x squared u, we can clearly see that both are multiplied by u, so we can take out a u and we have 1 minus 9x squared. So while it's a quantity and it seems a little bit more complicated, because both of our terms are multiplied by x plus 1, we can take out that entire quantity x plus 1, and we're left here with this coefficient, which is 1, and this coefficient, which is minus 9x squared. And I encourage you also, you can FOIL this out to make sure that you do come up with the equation that we had above, to convince yourself and to see how we can take out quantities like this. So now, here we have 1 squared minus 3x squared, because 3 squared is 9 and x squared is x. So we have a difference of squares, and we can turn that into 1 plus 3x and 1 minus 3x. By the zero product property, we will set each of these equal to 0 and solve. So we have x plus 1 equals 0, 1 plus 3x equals 0, and 1 minus 3x equals 0. For the first one, we subtract 1 from each side, and we get x is negative 1. Here I'm going to subtract 3x from each side, which will give us 1 is equal to negative 3x. And divide both sides by negative 3, and we get negative 1/3 is x. And here I'll add 3x to both sides, and we get 1 equals 3x, and we divide both sides by 3, and we get 1/3 is equal to x. So our solution set is negative 1, negative 1/3, and 1/3. And again, plug it in and check with our original equation to make sure that's correct. Again, rather than using difference of squares, we could take the 1 minus 9x squared, set that equal to 0, add 9x to both sides. We have 1 equals 9x squared. Take the square root of both sides, remembering that it's plus or minus. The square root of 9x squared is 3x equals plus or minus 1. Dividing by 3, we would get plus or minus 1/3 is equal to x. And so again, we get the same answer. So whichever you're more comfortable with. It is good practice to know how to do a difference of squares, but whatever you're more comfortable with. I think that as long as you're comfortable with it and it's a correct and valid way, then that is the best way to do it. So this is our last example here. We have 9y cubed plus 8 equals 4y plus 18y squared. Again, we can move all of our terms to the right or to the left. I'm going to move the terms on the right to the left. And I'm also going to write them in descending order, meaning my first term is going to be my biggest y exponent, which is 9y cubed. Now my next biggest I see here is a squared, y squared. So we need to subtract 18y squared from both sides. So we get minus 18y squared. My next biggest is just y. So we need to subtract 4y from both sides. So I have minus 4y. And then I still have 8 on this side. So plus 8 equals 0. Now, if it's difficult for you to do that all in one step, you're more than welcome to move everything to one side and then rearrange it. I'm going to show you why I wanted to do it like this. Now again, remember we're trying to factor. Now, y cubed and y squared both have a y squared. So I want to be able to take that out of both of them. So I'm going to be looking at this as one group and these last two terms as another group for what I'm going to be factoring out. So they both have, in this first group, they both have a y squared, and we have 9 and 18, so those are both multiples of 9, so we can take out a 9y from that. 9y squared times what equals 9y cubed? Well, that's simply y. And 9y squared times what equals negative 18y squared? Well, that's minus 2. Now this next one, only one term has a y, so we can't take out any y terms, but 4, we have negative 4 and 8. Both of those are multiples of 4. Now I don't really want to have a negative y. One reason is I can see here that I don't have a negative y. So let's go ahead and take out a negative 4. So negative 4 times what is going to make us negative 4y? Well, that's just y. And negative 4 times what is going to give us positive 8? Well, that's negative 2. And now, as you can see, we have both of our terms are multiplied by a y minus 2. So as we did in the previous equation, we can take that y minus 2 out. And what we're left with is basically, you want to know, what did y minus 2 multiply by? Well, here my y minus 2 is multiplied by 9y squared, and here y minus 2 is multiplied by negative 4, so you have minus 4. So all we did there is we just took out a common multiple of each of our terms, because we can see that each of them is being multiplied by y minus 2. Now again, on this one, we have a difference of squares. This is 3y squared minus 2 squared. So we can use our difference of squares to further factor this into y minus 2, 3y plus 2, and 3y minus 2. By the zero product property, we can set each of these equal to 0 to solve, and 3y minus 2 equals 0. Add 2 to both sides, we have y equals 2. Subtract 2 from both sides, we have 3y equals negative 2, which gives us y equals negative 2/3. And add 2 to both sides, we have 3y equals 2, so y equals positive 2/3. And our solution set is negative 2/3, 2/3, and 2. And again, plug any one of those or check all three of your results into the original equation to make sure that those do in fact satisfy our original equation. That's it for this lesson. Please check out the rest of the series in solving other types of equations. My next video, we're going to be looking at radical equations, so be sure to check that out. Thanks for watching.